All right, let's talk about one more situation where we may have the possibility that we want to compare our results from a classification technique to those of a regression technique. So let's take a look at the bike buyers data. And in this file, we have, well, now it's a data set inside Azure ML. We have numeric and regular versions of many of our attributes. Now, because Azure ML handles categorical attributes and creating the dummies for us automatically, and that's a more powerful technique than artificially classifying categories as some type of ordinal number in most cases. Let's go ahead and strip out those artificial numeric attributes. We'll still keep purchased bike and purchased bike numeric so that we can use the regression technique for purchased bike numeric and the classification technique for purchased bike. All right, so hopefully that was clear enough. Let's just start doing it and see if that helps. So we'll do a select columns in dataset first. And we will strip out all of those non-numeric or all of those numeric categoricals. Get rid of ID, marital. First, let's add all, and then we'll take away the ones that we don't want. So we'll get rid of ID, get rid of marital status numeric, gender numeric, education numeric, commute distance numeric, homeowner numeric, and I believe that's it. We want to keep purchased bike numeric. All right, so we'll save that. And now I'm going to move this split data over here and make a copy of it, because we're going to, first we need to pick our algorithms. Let's use linear regression on the left and a two-class neural network on the right. I'll stick with the defaults here. And linear regression, OLS, random number seed. Okay. So I'm going to add two more select columns. But in this case, because I'm going to the regression side, I'm going to keep everything except the normal purchased bike. And save it. This side, on my classification side, I will keep everything except for purchased bike numeric. All right. And then I'll connect down to my split data. And now I'll separate the sides completely by using this split data to feed my train model and score model pills. I need to go to my train model here and change my column name to, I believe, purchased bike numeric. Purchase bike numeric and purchased bike. Okay, so let's fix that. All right, so I'm splitting 75, 25 in both, scoring the model. I won't be able to evaluate the models together anymore. So I'll need to create another evaluate model pill, and we can look at each one independently now. All right, so let's submit this job. All right, our new job is running. And you can see we've got a number of steps to go through, so I'll pause the video until it's finished. Okay, our job has finished. And we can look over here at the to class evaluate model and see how it did. And we see that this one's just okay. It's got an AUC of 0.658, accuracy of 61.2%, and the confusion matrix right there. Now, with the evaluate model for the regression, we get our standard R squared and RMSE, MAE, which aren't really all that comparable. And in essence, this is a classification problem. So we need to figure out how we can convert this evaluate model, or we can convert these regression results to a classification tool for evaluation. All right, so let's take a look at the score model and preview the data, and we can take a look at the scored data set there. So we have 250 rows of data. Which is not bad. Since we didn't have a ton to start with, that's fine. Now, copying and pasting is a little problematic from the display that we'll see, that we can see with the score model. So what we can do instead, I'm going to go back to my experiment, and I'm going to look for a CSV tool here. Convert to CSV. And I'm going to take that scored data set and bring it right into that convert to CSV. I'll run that job, and then we'll see what we can do with that newly created CSV. Fortunately, everything's already run, so really the convert to CSV is the only thing we need to wait for. That one is done now. If I right-click on Convert to CSV, I can select the Access data here, and I can access the results data set. And when I get here, I see I've got data.csv, which I can then click on over here and download. So we'll save that as, actually, let's just open it right up. All right, so I've got my marital status, gender, scored label, and the purchased bike. So I'll convert this to a table. Here we can calculate our actual prediction. Just by rounding, we'll just use the 50% rule, so we'll just round. So at this point, we can say, okay, is it accurate? If prediction equals actual purchased bike numeric, whoop, I have to finish this, then 1, else 0. Okay. I can actually build a confusion matrix here. So what I need are true positives, false positives, true negatives, and false negatives. So for true positives, equals if, and then I'm going to, for my logical test, use and. So the and function. So my first logical and will be prediction equals 1 and accurate equals 1. So that would be a true positive. So if all that, then 1, else 0. Okay. So these are my true positives. Now I'm going to copy this over one more. And I'll change if my prediction is 1 and accurate is 0. That's my false positives. Copy it one more time over. If my prediction is 0 and accurate equals 1, these are my true negatives. And my false negatives will be if my prediction equals 0 and my accurate equals 0. Those are my false negatives. All right. So now let's go to our table design. Let's use a total row, and I'll go down to the bottom. So my prediction, my accuracy, we have 250 rows of data. So for my accuracy, I want the average, 64.4% accurate. For these, I want to count 250, Actually, no, I want my total. Sum Well, I must have missed something here because let's see, if prediction equals 1, accurate equals 0, then I have a false positive. So I should have a 1 there. Let's see what's going on. That should be equals 0. So let me see. Yeah, I messed up all of them. All right, so I have to do fix that with an equal sign. All right, that makes more sense. And all 4 of these numbers should add up to 250. Yeah, they do. I can now create a confusion matrix with my predicted and actual. So my true positives will be this one here. My false positives will be this one here. My false negatives will be this one here. And my true negatives will be this one here. All right, so I can now calculate accuracy, precision, and recall. All right, 0.644. That's the number I had before. All right, so let's take a look at precision and recall, and then we can calculate the F1 score. So precision will be my true positives over all my positive predictions, which would be my true positives and my false positives. So let's see, that would be this divided by all my predicted positives. Okay, 0.65. We can format the number of decimals in a few minutes. All right, so recall is my true positives over my true negatives plus my false negatives. All right, so true positives, so that's this divided by true negatives and false negatives. Now I can calculate my F1 score, which is 2 times precision times recall divided by precision plus recall. So 2 times precision times, equals 2 times precision times recall divided by precision plus recall. And so our F1 score is 0.568. Let's go ahead and make these all the same number of decimal places. Yeah, 4 is fine. All right, so we can now compare our model's accuracy, precision, and recall with the accuracy, precision, and recall and F1 that we had for our classification model. So let's bring both of those up side by side. Let's see if I can squeeze this down a little bit so we can see everything. Scroll over here to the right. All right, so I've got accuracy of 0.644, which is a little bit better for my regression model. Precision, 0.65, better than 0.609. Recall, 0.5035, not as good as the recall in my classification. And my overall F1 score, 568 versus 591. So the recall ends up being the big differentiator here. I can't calculate the AUC, so my second metric is F1 without knowing what my expected distribution of positive and negative cases is. And then precision and recall as subfunctions of F1, whether I would expect to have one case be particularly rare. Am I more interested in being overly permissive or being permissive, or would I rather have a more restrictive model? So all of these come into play. We'll continue on our approach toward trying to come up with a good evaluation technique that allows us to bring cost into the equation as well. All right. Hopefully this helps out, and you can now compare classification and regression techniques against each other.